This screencast is on graphing systems of equations and finding the point of intersection. So we're going to start with an example, y equals negative 3x and y equals negative 4x plus 2. So we are going to start by graphing. I'm going to graph this first equation with red. So I'm going to identify my y-intercept, which is at 0. So I'm going to zoom in a little bit, and put a point at 0. And then my slope is negative 3, so I'm going to go down 3 units and over 1 to the right and plot a point. I'm going to do a couple more points going down 3 over 1. Zoom out a little bit. Down 3 over 1. And you only need 2 points to draw any line, but I like to have a couple extra. I'm also going to go in the other direction from my y-intercept. I'm going to go up 3 over 1 to the left, so I have some points in that direction as well. I'm going to connect my points, and I now have my line y equals negative 3x. With blue, I'm going to graph my other equation, y equals negative 4x plus 2. I'm going to identify my y-intercept at positive 2. So I'm going to draw my point, and then my slope is negative 4. So I'm going to go down 4 over 1 to the right. 1, 2, 3, 4. And I can see right here that I'm going to have my point of intersection. Both lines are going to cross at that point. I'm just going to add a couple more. And then I'm going to do a couple at the top. So I'm going to go over 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. And then I'm going to connect my points. So looking at the graph, we can see that both lines are going to intersect at this point here at 2, negative 6, right here. So that's going to be their point of intersection. So what we call their POI. So POI is going to be written as an ordered pair with the x value first. So we have 2, comma, negative 6. So we solved and we found the point of intersection as 2, negative 6, but now we just want to make sure, and we're going to do it algebraically. So I'm going to take my first equation and I'm going to plug in x and y. So I'm going to say negative 6 is equal to negative 3 times 2. And I want to make sure that both the left and the right side are equal, which it does work out. And then I'm going to plug in my negative 6 for y equals my negative 4 times 2 plus 2 to see if my left and my right sides are also going to be equal. And they will. They'll both equal negative 6. So the point of intersection for our two equations is 2 and negative 6. So in example 2, we are going to find the point of intersection for our two equations. And I'm just going to zoom in a little bit. And I'm going to use red for the first equation again. So our y-intercept is located at negative 4. And then our slope is 1. So we're going to go up 1 over 1. So we're going to have a bunch of these points. And we can connect them and draw our line. We're now going to graph the other equation, which I'm going to put in blue. So my y-intercept is 10. And then our slope is negative 1. So we're going to go down 1 over 1. And we can do a couple points, and then we can connect them. And then we can identify the point of intersection. So if we look at our graphs, we can see that the two equations are going to cross at when x is 7 and y is 3. So our point of intersection, POI, is going to be 7, 3. And if you want to be sure, we can plug these back in to make sure that it does work out and we got the right point of intersection. So I'm just going to do a little brief check down here at the bottom. So 3 equals 7 minus 4, which is true. 3 equals 3. And then 3 equals negative 7 plus 10, which is true because 3 would equal 3. So it does check out. So when x is 7, y is 3 would be your point of intersection for example 2. For example 3, we are going to do the same idea. So y equals 2/3 x minus 2. I'm going to make that purple. I'm going to identify my y intercept, which is -2. So I'm going to put a point at -2. Okay. And then my slope is 2/3. So I'm going to go up 2 over 3 to the right, up 2 over 3. And I'm going to do a couple more points. And I'm going to go do some to the left. So go down 2 over 3. And then we can connect them and form our line. With my blue, I'm going to graph the other equation, which has a y-intercept of +3 and a slope of -1. So I'm going to go down 1 over 1. And I can find my point of intersection. I found it at 3, 0. So I'm just going to add a couple more points, and then I'm going to draw my line. So looking at the graphs, when they intersect, we'll have a point of intersection at 3, 0. So our POI in parentheses is 3, 0. And again, it's always a good idea to check to plug those x and y values back in. For example 4, we are going to graph the two equations. I'm going to make the first one purple, and that is -2x plus 3. I'm going to identify my y-intercept as +3, so I'm going to plot my point. And then my slope is -2, so I'm going to go down 2 units over 1 to the right. And I'm going to do a couple of points and draw my line. So we're also going to draw the line for the other equation, which I'm going to make this time blue. So my y-intercept is -4, and my slope is also down 2 over 1. So I'm going to go down 2 units over 1, and I'm going to draw a couple points going in either direction. So up 2 over 1, and I'm going to connect them and make a line. So we want to find the point of intersection, the POI. And if we take a look at our two graphs of our lines, these lines are parallel, so they will never, ever, ever intersect. So the POI, we don't have one. There is none. So these lines are parallel. Parallel lines never intersect. Ever. And an easy way to tell if they're parallel lines is that they will have the same exact slope. So if we go up to the equations, both slopes are -2. So the parallel lines will never intersect, and they have the same exact slope. So that's an easy way to tell. For the last and final problem, example 5, we are going to graph the two equations. So I'm going to first graph my y equals 2/3 x minus 10/3 in purple. So -10/3 is -3.3 repeating, so I'm going to go down in between -3 and -4 and put my point. And then our slope is going to be up 2 over 3. So this is kind of like a weird point, so I'm going to just kind of eyeball it as best as I can. I'm going to go up 2 units over 3. So somewhere around here. I'm going to do a couple more points. And then I can connect my line. All right, to graph the other line, we first must get this in y equals mx plus b format. So I'm going to divide everything by 3. So that will give me y equals +2/3 x minus 10 over 3, which is the same exact equation that we did a couple minutes ago. So when this happens, when both equations give you the same exact line, this is going to be infinite solutions. So any number, any x and y is going to be a point of intersection because it is the same line. So all points are going to work. So it has infinite solutions for our point of intersection.